It's math time with Heinz. It's math time with Heinz. Math time.
All right, everybody, so we're going to jump into lesson 5 and lesson 6 today. We're going to do a little bit of both. I don't need to go through the whole lesson because of COVID this year. We're going to cut it down a little bit. But let's do a little bit of lesson 5, then we'll jump to lesson 6, do a little bit there. I'm just adding 2 little new things today, nothing crazy. Some big ideas, but nothing crazy. So here I have a unit circle with a triangle drawn in it. I have a quadrant 1 angle drawn here with my triangle. So here I have my x value, and here I have my y value, right? So with respect to the values of x and y, where are sine and cosine? So what does x equal? Well, I'm in the unit circle, so I have a hypotenuse of 1. So adjacent over hypotenuse, we need to remember that the cosine of theta is x, and the sine of theta is y. So in this triangle, the cosine of theta is this horizontal distance, and the sine of theta is this vertical distance. So using triangle trigonometry, what's tangent? This lesson 5 is all about tangent here. So what's the tangent of theta with respect to x and y? Well, tangent is opposite over adjacent. Tangent is y over x. Or in terms of trigonometry, our other trig functions, the tangent, opposite over adjacent, y over x, it is sine over cosine. That's the whole idea of this lesson here. What is tangent? Tangent is the ratio of sine over cosine. Instead of thinking about it as opposite over adjacent, we still can. It is still opposite over adjacent. But instead of just using that, I can use sine, opposite over hypotenuse, divided by adjacent over hypotenuse. Well, when we do the division, when we keep, change, flip, our h's cancel out there and we're left with O over A. So that's why tangent equals sine over cosine. And I'm going to say it a whole bunch of times, tangent equals sine over cosine. You don't really need to memorize it, because if you can draw me this unit circle triangle with cosine is horizontal, sine is vertical, you're good to go. Because you can look at this triangle and say, what's tangent? Tangent is opposite over adjacent, sine over cosine. Huge idea. We're going to use it going forward. We're going to skip ahead to page 22 here. So why do we call it tangent? Why do we call it tangent? Well, we call it tangent because it's literally tangent. So what does that mean? So looking at this here, OP is 1 because it's a hypotenuse of the unit circle. I know that PQ is vertical, that's sine. PQ is this vertical distance here, so that's the sine of theta. OQ is cosine, because that's my horizontal distance in the unit circle. But then notice I'm making a bigger triangle here. Notice I'm making this bigger orange triangle here. That's not in the unit circle. That's outside of the unit circle there. So what's the length of OS? Well, this bigger distance here, OS, that's a radius. That's 1. So what is this vertical distance here? What is this vertical distance here? Well, notice it touches the circle once, which something in mathematics, if something touches it once, we call it a tangent. So guess what this side ends up being? And it comes from similar triangles. So I have my little triangle here, my 1 cosine triangle. And then I have this bigger triangle that's 1, we don't know what that is. And I know they're similar because they both have right angles and they both have angle theta there. Oh, the bell's ringing. So, since they're similar, so triangle PQR is similar by angle, I can set up a proportion. Question mark over 1 question mark over 1 equals sine over cosine. So what this tells me, well, what's that? Anything divided by 1 is just itself. That question mark there is tangent. Sine over cosine is the tangent of theta. So physically, when we find the tangent of theta, this is what we're finding. We're finding the vertical distance created by that terminal ray. That terminal ray and being tangent to the positive x-axis in the unit circle. That's the distance we're finding when we create the tangent of theta. So the tangent of theta is this vertical piece of that triangle. Okay? I think that's all I want to say right now for that. Another bell's ringing. You're just going to hear lots of bells ring. And I'm going to jump into lesson 6. So the big idea here is that tangent of theta equals the sine of my angle over the cosine of my angle. I actually want to do one more problem in here. Slide into number 7 here. Number 7. So the terminal side, I'll give you a second to get there. So the terminal side of an angle in standard position intersects the unit circle at this point. So let's draw a picture. Let's draw a picture. I intersect the unit circle at -5/3, -2/3. So this point here is a quadrant 3 angle. It's a quadrant 3 angle I'm dealing with here. So I spin into quadrant 3 and I get x, y. But I'm also in the unit circle. So that's 1. And in the unit circle, my x value is cosine. Only when I'm in the unit circle. X is cosine and y is sine. So I can look at this here and say, well, that's my x and that's my y. So it's sine over cosine. The tangent of theta equals sine over cosine. So I end up getting what? Sine over cosine. -2/3 over -5/3. Well, how do I deal with a fraction? I keep fraction divided by a fraction, keep, change, flip. Keep the top, multiply it by the reciprocal. Those 3's divide out, and I'm left with -2 over -5. Well, 2 negatives divide to a positive, 2/5. So again, sine over cosine, opposite over adjacent, and in the unit circle, it's sine over cosine. So I just found sine over cosine and then did some 7th grade work with fractions. I'm going to pause the video while I switch to lesson 6. So here we are in lesson 6 where we're going to talk about the reciprocal trig functions. So there's actually other trig functions in sine, cosine, and tangent, and I promise you it's not too bad. We're going to talk about some of them and then we'll do some problems. So for each of the following segments, state its length as sine, cosine, tangent, or 1. So we've got our triangles here that we've been working with. OQ. OQ is this horizontal distance here. That's cosine theta, right? Horizontal is cosine. PQ is the vertical distance in the unit circle. That's the sine of theta. OP. OP is a hypotenuse, so that's 1. And then a couple minutes ago, we defined this vertical distance outside the unit circle, RS, as the tangent of theta. That vertical distance there represents the physical length of the tangent of theta. So there's this other trigonometric function called secant, the secant of theta, which we abbreviate as SCE. And the secant of theta is what? Well, we're going to use similar triangles again. I have one cosine, sine, and then we have that tangent triangle. The tangent triangle has a vertical distance of tangent here. Horizontally, it's 1. So what we did is we've defined this hypotenuse here as the secant of theta. Physically, the secant of theta is the length of that terminal ray and that perpendicular line intersecting. So what is secant theta? Well, secant of theta, so let's set up a proportion. Secant over 1, hypotenuse over adjacent, equals hypotenuse over adjacent, 1 over cosine. So the huge thing here is there's this new trigonometric function called secant. What is secant? Secant is the reciprocal of cosine. So secant is this new trig function. Secant is the flip, the reciprocal of cosine. Secant is the reciprocal of cosine. So if I know cosine, what does reciprocal mean? Flip the fraction. Secant means flip it, and you get that value there. You get the length of that, that hypotenuse of that bigger triangle in the tangent world. Okay? So quickly, if cosine is 5/13, what is secant? Well, if cosine is 5/13, secant is the reciprocal of that. 13/5. Done. That's it. If we know cosine, we also automatically know the value of secant. Let's look at number 4. If sine is 7/25, so sine is 7/25, and oh boy, where do I live? Well, pi is 180. 180 cut in half is 90, so I live in quadrant 2. And I know the sine of my reference angle here is 7/25. What's the value of secant? Well, if I want to know secant, I better know what cosine is. So how do I find cosine? Well, I've got to do a little Pythagorean theorem. 7 squared plus x squared equals 25 squared. And to save us some time here, we're going to say x equals 24. But look at your picture. It's going in the negative direction. So it's really a negative 24. So draw a picture, Pythagorean theorem. I can find cosine. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse, which buy one, get one free. If I know cosine, I also know the value of secant. Secant is the reciprocal of that. Hypotenuse over adjacent. Secant is the reciprocal of cosine. Okay? If I give you secant, again, buy one, get one free. If secant is 6/25, that tells me cosine is his reciprocal, 5/6. Buy one, get one free. So I can now find sine and tangent by doing what we did up here, drawing a picture, Pythagorean theorem. I'm not going to do that, but just know we get this with these reciprocals, the secant function, it comes from cosine. There's 2 more, and it comes from similar triangles again. There's this guy called which is also known as cosecant. Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So if I take tangent and flip it, I get cotangent. So if I take tangent and flip it, I get cotangent. But we just learned tangent is sine over cosine. So if I flip that fraction, I get another way to define cotangent. Cotangent is cosine over sine. But again, these are our reciprocal functions. And the hardest part is just knowing who matches up with who. So we have these functions called secant, cosecant, and cotangent are our 3 new trigonometric functions that come from taking a reciprocal. Let's do a problem, and this will hopefully make more sense. So if angle alpha is a terminal ray in quadrant 4, so I live in quadrant 4, drop to the x-axis, where the cosine of alpha is 1/3, cosine adjacent over hypotenuse. Find the value of the other 5 trigonometric functions. Well, let's do some Pythagorean theorem first. Leg squared plus leg squared equals hypotenuse squared. 1 plus x squared is 9, so x squared equals 8. X squared equals 8, so that's the square root of 8. But notice it's going down and yelling timber. So I'm going to put a nice negative there. I'm going to put a nice negative square root of 8. Okay, I drew my picture. Now I can find all 6 trig functions. I like to start out with sine, cosine, and tangent. Let's start with those. The sine of my angle is negative radical 8/3. The cosine of my angle, well, we already knew that, is 1/3. And tangent opposite over adjacent, there we go. But now we also have 3 other trigonometric functions. We now have 3 other trigonometric functions, and it's just knowing who goes with who. Cosine gets secant. Notice, cosine and cosecant do not go together. Notice the front letter changes. When you take the reciprocal, the front letter they don't match up. The S's don't go together, the C's don't go together. So cosecant goes with sine, secant goes with cosine. So again, buy one, get one free. We know what sine is, cosecant, I just need to flip it. -3 over radical 8. Secant, 3 over 1. Cotangent, flip it, -1 over radical 8. I can get all 6 of these trigonometric functions just by finding the first 3 and flipping them. Secant goes with cosine, cosecant goes with sine. Clearly, tangent and cotangent go together. I'll do one more problem and call it a lesson. The terminal side of an angle passes through this point on the unit circle. So right away, I know x and y. I'm on the unit circle, so I already know sine is vertical. Sine is 2/5. I know cosine is negative square root of 21 over 5. I know sine, I know cosine. How do I find tangent? Well, tangent is sine over cosine. 2/5 over negative radical 21 over 5. Which luckily, if we keep change, flip it, those 5's divide out, and I'm left with 2 over negative square root of 21. So again, you could have drew a picture and done Pythagorean Theorem, and so you could have done all that, or you could realize I'm in a unit circle. X is cosine, y is sine. Well, it said all 6 trig functions. So sine goes with cosecant. Cosine goes with secant. They're reciprocals. So what is secant? We'll take that fraction and flip it. 5/2. Take that fraction and flip it. -5 over radical 21. And cotangent, I'm going to take this fraction and flip it. Done. Okay? So knowing I'm on the unit circle is powerful because that tells me x is only on the unit circle. X is cosine, y is sine. And I'll see you guys in person or on the next video.